So an integer array is given of size n, and I want to find the length of longest subarray with sum 0. Length of longest subarray with the sum equals to 0. I think I can give you an example to start with. So let's say your array contains something like this. 1, 2, 3, and then minus 5, and then 1, and then minus 1, and then 9. 1, 0, minus 1, and then 9. Can you tell me the answer for this? What is the length of longest subarray in this array which has a sum equals to 0? 6. And what are the elements involved in those 6 elements? Can you name those elements? Let's type that quickly. From 2 to minus 1. Right. Because the portion that gives me this 0 sum is just from here to here. Because the sum of this is 2 plus 3, 5 minus 5 is 0. And then this is also 0. So 0 is the answer over here. Okay, cool. So tell me the brute force approach for solving this at least. What would be the brute force approach here? Yeah, you can consider all the subarrays. So that is n square approach. I had talked about this in previous class. I am not going to talk about this again. Now let us understand how is it going to go about. So one thing is for sure, in the last class we had seen, if let's say a particular prefix sum till here is equals to x, and then again another particular prefix sum till here is equals to x, that means that the sum of portion from here to here would definitely have been 0. How? So in the last question I just had to check whether such kind of subarray exists or not which has a sum 0, but here I am concerned about length also. So how will you be able to measure this length? If let's say this is index I and this is index j, how will you be able to measure this length? Is j minus I plus 1 the length over here? Tell me that. The length is not j minus I plus 1 because this element doesn't contribute to the subarray which has sum 0, right? This minus this, that means you are letting go of this. So the size of that would be I minus j. If this is I and this is j, the size of this subarray will be I minus j. So what I can do is that the map that I am creating, previously it was a map of just prefix sum followed by 0 or 1, let's say 1. Okay, but now it will be prefix sum followed by index. And the moment I see that a prefix sum has repeated, I'll just check for this thing. And if this is longer than all the previous lengths, then I can always update my answer. But I have one question over here. By the way, what is an important thing over here? Let us see what happens here. So if I write down the prefix sums, it is 1, 3, 6, 1, and then 2, 2, and then 1. So I can see that this 1 first came here, then came here, then came here. So tell me, with respect to the repetition of 1, how many subarrays are you able to see that have a sum of 0? Okay, 2 is not the right answer, please think. With respect to the repetition of 1, how many subarrays are you able to see? So this 1 got repeated over here, so this portion has a sum 0. That is the reason 1 came here again. Now this 1 got repeated over here, so this portion also has a sum 0. And also I can say that this 1 got repeated here, so this entire portion also has a sum of 0. So there are 3 subarrays that have a sum of 0. Did you notice it? That there are actually 3 such subarrays with sum 0. So which one do you want? Let me call it first one, call it second one, and call it third one. Which one do you want? You would actually want third one because you are interested in the longest length, right? So answer me one question. How will you be able to find this length only? Because 1 can repeat several times. So let's say a prefix sum repeats again. Will you want to update its index? No. That is the point over here. Yeah, because it's a common sense. Let's say a prefix sum repeats over here, and it had come at several places before. Let's say it had come here, here, here. So you would want to maximize the length of the subarray. So instead of storing this index or this index, you would store this index so that you get this length, which is the longest one. Because although this will also have zero sum, this will also have zero sum, this will also have zero sum, this will also have zero sum. But the point is that if you store the index of this or this, you will get a smaller length. But if you store this length, you will get the length that you are actually interested in. So I think this is easy to understand that the map that I will create, it will be a map of prefix sum comma something. And what will be that something? That something will be the index of first occurrence. Index of first occurrence of that particular prefix sum. Right? Now that is the way you keep on tracking the things, and that's how your job gets done. Okay? So cool. How am I going to, write the code for this? So in the last question, once I declared my map, so it will be a map of integer comma integer. It will be an unordered map. I can have an unordered map. Okay. So tell me one thing. Here, I need to take into consideration the empty prefix also. So empty prefix has a sum of 0. So I'll initialize my prefix sum as 0. So you would want to make an entry for the empty prefix sum also. Yes or no? Because 0 can also repeat at the end, right? What will be the index that you would have corresponding to it? Yes, index will be -1. Yeah, I think that makes a lot of sense, because just think of it in this way. You had something like 1, 2 and then -3. Okay, so the prefix sums are 1, 3 and 0. So if let's say for this prefix sum 1 you have index 0, for this you have index 1, and for this you have index 2, then if you are storing 0 as this much of prefix sum, you can have its index as -1, because only then once you do 2 minus -1 you will get this length of 3. So that is the reason I'll initialize my map with, I'll do map.put, I'm writing pseudocode only, okay, prefix sum along with the index I. Okay, and once you have stored this prefix sum and this, then you can just go ahead. So now you can start iterating from 0 to n-1, and every time you will do prefix sum plus equals to a of I. Can you tell me what should I do after this? If let's say this is the first occurrence of prefix sum, by that I mean if this key is not present in the map, what should I do? If this key is not present in the map, should I simply put it in the map? Because it can never happen that there is a subarray that ends here and has a sum of, yeah, cool. So if this is the case, in this case what you can do is, let's say this is your map, you can do map of prefix sum equals to the index. Okay, and when will you do this? You will not do it just like that. If you see that map does not contain it, so for that the check is if map.find prefix sum equals to map.end. I talked about it in the last class. So if this is the case, then you will simply insert this thing in the map by doing map of prefix sum equals to I. Else what to do? Else tell me. Let's say you are tracking an answer, which is your length, you initialize it to -1. Else what should be done? Otherwise, there is a prefix sum which already occurred somewhere, okay, and its first occurrence is stored in map of PS, okay, then I can just compute the length between current occurrence and the first occurrence. So it will be, so my answer would be either answer, or it would be my current index I minus its first index, which was map of PS. So this is the way I'll keep updating my answer, and finally I can just return my answer. What is the time complexity here? Let's say you are using an ordered map or hash map in which add and insert, add and get, everything is order 1. How much time will it take? Yes, it will just take order of n time. Okay.